Hi, I'm Elisabeth Palix. I'm a chemical engineer working for EDF Renewable, and I'm going to talk about the challenges linked to rocky substratum. As you can see on this picture, there are many type of rocks that we can find that are outcropping in France. To see that you can look at the cliff we have on the French coast, or even at the building we have. If we go back to the offshore renewable project we have on the French coast, you can see that we have few projects in chalk, like the FEM and the Tribune project. We have few projects involving limestone, like Coastal, Saint-Nazaire and Noirmoutier. And we have even a project involving granite, the Saint-Brieuc project. Due to this particularity of the French ground condition, we thought that it would be interesting to get our own guideline for recommendation of planning and designing foundation of offshore wind turbines. So the French Committee of Soil Mechanic set up a group to work on that matter, and we issued some guidelines that contain some guidelines typically for rock. Rock is often not discussed in the international standard. The main question we have when we start a project where there is a rock outcropping is how to adapt the site investigation and the laboratory test to the rocky condition, or we can do the installation of the foundation on those rock. What will be the behavior at the interface between the rock and the pile? What will be the effect of the lateral loading on the mass of rock surrounding the foundation? And what will be the impact of cyclic loading? So depending on the project, the answers to those questions will be different. It's very site specific, and I'm going to give you some examples. For example, the FEM project, so seated in chalk. The first question we had to answer is, can we rely on driving through a flint band? As you can see there on the picture, and the answer was no. We didn't take the risk to get a pile or monopile driven through this very hard band of flint. So we went for a GPS concept. So the question then was the weathered upper chalk, was it strong enough to for a GPS concept. So for that we did run some quite specific site investigation involving a very large fiber core. So the idea was to get some intact samples, because the first samples we get from drilling on normal size fiber core diameter were quite disturbed by the drilling operation. So we acquired some fiber core of 50 centimeter diameter, and then we tested those samples, so very big samples, in a 300 millimeter cell from the thermos, and we looked at the strength of the chalk, but also at the evolution of the stiffness through cycles. Another example is the case of a jacket seated in chalk. So as you can see on the picture, when you drive through chalk, you will disturb, you will completely remove the chalk around the pile, and you will also induce some fractures. In very soft chalk, or as the UK people say, low to medium density chalk, the consequence is to get a very low friction along the pile. So the Syria and even the French norm provide some very low friction capacity for this type of weather chalk. And there are also some uncertainty on the strength of this friction through the time. So we speak about aging effect or setup through the time. So many uncertainty. The French Committee of Soil Mechanic recommended to use some higher safety factor in choke due to those uncertainty, or to run some onshore tests. So on this slide you can see 3 examples of onshore tests, offshore tests that have been run. So the first one is for the Tribune project, where you can see some axial tests. The Wikinger project even consider offshore test. You can see the sketch of the once again axial test, and at the bottom you can see the Alpaca project that run both axially loaded and laterally loaded tests on an onshore site. A third case is a case of drilled and coated monopile or driven monopile. So around the monopile there are many contribution to the lateral capacity, like the distributed lateral load or shear force that you can get at the bottom of the monopile. Generally in rock it's simplified by just some lateral springs along the monopile. But the question is which kind of lateral spring will you use? So will you use something that is quite similar to clay, or something that will show a brittle behavior after a certain displacement, or will you use different PY curves depending on if you are on a broken zone or in a more deeper area of the pile? To answer this kind of question, EDF Renewable runs some onshore pile tests in a former quarry to test the behavior of a pile in weak calcareous rock. So we installed 11 piles up to 1.5 meter diameter, and we did run some static and cyclic tests. The particularity was to apply the load at 5 meter depth to reproduce the horizontal and load and moment that you will get on a monopile. So here you can see some of the observation we made during those tests. So the gap behind the pile, the crushing of the rock around the pile, like you got for choke, cracks that you can observe during the driving or even after doing the lateral loading, and an example of cyclic tests that show the evolution of the displacement through cycles. So after those tests we run a thesis, and we reproduce those elements in a 3D finite element software to try to quantify the effect for a real monopile. And I should also mention the SolSip Plus project that is run through France Énergie Marine. So this project is a follow-up of the SolSip INR project. The idea was to provide some guidance on the effect of cyclic loading for monopile. So we tested sand, but also calcareous rock like chalk and limestone. The University of Lille looked at the synthesis of all the knowledge we have in France onshore, and did also some modeling. And the 3SR laboratory ran some quite advanced laboratory tests. You can see on the bottom left figure the 3SR apparatus that is testing in 3D the interface between rock and rock or rock and grout. So in conclusion, the composition of the rock, the structure like the porosity and its history has a great effect on the behavior of a foundation. A rock is a very heterogeneous material by nature, so it provides also very heterogeneous results when you run some laboratory tests. So you need to account for that when you quantify the number of tests you should do. The installation and the design are very closely linked, so they really need to be looked at together. You won't get the same design parameter, design methodology, depending if you drive a pile or if you drill it and grout it. There is still some work to be done by the industry. As you can see, there are several GIPs ongoing, like the Alpaca or also the Solcip Plus project. One of the questions that is still open, I understood from the Alpaca project, is can we rely on the aging effect in chalk? It's quite important to know at which moment you can start to load your foundation. So depending on this robustness of the aging effect, you can save quite a lot of time. There are also many topics I didn't discuss today, like jacking on hard ground, cable protection. So there is still a lot of work to be done to understand that. But hopefully, after the first few offshore projects in France, we will know a lot better on the interaction between the foundation and the weak rock. So thank you for your attention, and if you have some question, you are more than welcome.